Hello everyone. Today we are going to discuss about momentum and impulse. In physics, momentum is defined as the product of mass and velocity. Okay? The product of mass and velocity of a body is what is known as momentum. Momentum is equal to mass times the velocity. Okay. Momentum is represented by the small letter P. This is equal to mass times the velocity, can be U or V, showing initial velocity or final velocity. So therefore, if we are considering the final velocity, momentum will be m times v. Okay, so P is equals to mu or P is equals to mv. So momentum is when you multiply the mass of an object with its velocity. U is the initial velocity, V is the final velocity. All right? Okay. So if a body is at rest, that is, the body is not in motion, or when a body comes to rest where its final velocity is 0, then it means that body or object does not have momentum. So for a body to have momentum, it needs to have a velocity, okay? And it has to be an object that has mass. All right. So the SI unit of momentum, since we say momentum P is equals to mass times velocity, let's just use final velocity for now. It doesn't matter. So the unit of mass is kilogram, so that will be kg multiplied by the unit of velocity is meters per second. So therefore, the unit of momentum can be kilogram meters per second. Okay, if you want, you can represent it as kg m per second, like this. Is the same. Well, we can represent momentum. Well, we can represent momentum as kilogram meters per second, or there can be another unit for momentum known as Newton seconds. We will talk about that. Okay? NS. So the unit of momentum is either kilogram meters per second or Newton second. All right? Unit kilogram meters per second, that is kgm per s, or it can be Newton's seconds. We will talk about that. And bear in mind that momentum and impulse, which we will discuss later, they have the same unit and dimension. Okay? Momentum and impulse have the same unit and dimension, but they explain different things. We will come to that. Momentum for now is the product of mass and velocity. So how do we state the dimension of momentum? If momentum, the unit, let's say the unit is what? We said kilograms meters per second. So kilogram is referring to mass, okay? Meters is referring to length, and per second is referring to time. So if we want to represent this as a dimension, it will be mLt to the negative 1. Okay, that is the dimension of momentum. M for kilogram, okay, L, which is the length, is the meters, and T, which is time, for the seconds. So the unit of momentum is kilogram meters per second or Newton seconds, but the dimension is mLt to the negative 1. All right. We move on. We have a problem here, and it says a ball of mass 800 grams, is projected at 30 meters per second. Calculate the magnitude of the momentum. So the mass is 800 grams. If you convert that to kilograms by dividing it by 1,000, you will have 0.8 kilograms. And the velocity that it is moving at is 30 meters per second. So momentum is mass times the velocity. So momentum will be the mass 0.8 multiplied by the velocity is 30. So 0.8 multiplied by 30, you have 24 kilograms meters per second, or if you want, you can say 24 Newton seconds. Okay, that will be the units. We move on to the second question. It says a body of mass 8 tons moving at 0.6 meters per second. What is its momentum? So the mass is 8 tons and the velocity it is moving at is 0.6 meters per second. What is its momentum? So we know that momentum is equals to mass times the velocity. But the mass is given in tons, so we have to convert it to kilograms. You should know that 1 ton is equal to 1,000 kilograms. So if you have 8 tons, that will be, let's say, X. So when you cross multiply, X will be 8 tons multiplied by 1,000 kilogram divided by 1 ton. So tons cancel tons, so which means that will be 8 times 1,000. That is 8,000 kilograms. So in short, if you have tons, you want to convert it to kilograms, just multiply it by 1,000, right? Okay, so the mass will be 8,000 multiplied by the velocity 0.6. 8,000 multiplied by 0.6, you have 4,800 kilograms meters per second. Okay, we move on. We have another question here. It says a steamroller of mass 5 tons has a momentum of 3,000 Newton seconds. What is the velocity at which it is moving? The mass is 5 tons, which is going to be how many kilograms? By multiplying it by 1,000, you have 5,000 kilograms. Okay, the momentum is given here as 3000 Newton seconds. So we are asked to find the velocity at which it is moving. But we know that momentum P is mass times the velocity. So if at all we want to find the velocity, you divide both sides by m, u, which is the velocity, will be momentum divided by the mass. So what is the momentum given is 3000 divided by the mass of the object is 5000. So what is the velocity? 3000 divided by 5000, that is 0.6 meters per second. So that is the velocity at which the steamroller is moving. Okay. Impulse refers to the change in momentum. Okay, the change in momentum is what we call impulse. So if you have an object that is moving, it has an initial velocity and it has a final velocity. So the change in momentum will be the final momentum minus the initial momentum. Okay, so but let's try to define it first. What is impulse? Impulse is defined as the product of force and time that causes a change in the momentum of an object. So impulse is equal to force multiplied by the time. Impulse can be represented by the letter J or I in some textbooks, is equal to F multiplied by T. So J impulse is Ft. Okay, so in physics, when force is multiplied by the time, we refer this as the impulse. Okay, so but you should also know that impulse means change in momentum of an object. Okay, so how will we explain this? If we have an object, let's say we have an object, okay, that is initially at this position, it has an initial velocity of u, okay, this is the mass of the object, and it reaches a point here with a final velocity v. This is the initial position and this is the final position. So the initial momentum P initial will be mass times the initial velocity u. The final momentum P final will be the mass times the final velocity. Okay, so the change in momentum delta P is P final minus P initial, that is the final momentum minus the initial momentum. So the change in momentum will be mv minus mu. So we can say change in momentum is equal to m. If you factorize that, you'll get v minus u. So this change in momentum is what constitutes the Newton's second law of motion. So according to Newton's second law of motion, it states that the rate of change of momentum is directly proportional to the resultant force. Okay, this is what Newton's second law of motion states. The rate of change of momentum is directly proportional to the force. So it means the change of momentum divided by time is proportional to the force. That is what Newton is trying to explain in his second law of motion. Okay, so if you are dividing anything by time, that is what we call rate. So that is the change of momentum divided by time is directly proportional to the resultant force. So I can represent this as delta P, which is the change in momentum divided by the time t. This is equal to F. Okay, if the proportionality constant is equal to 1. All right, so the change in momentum can be, if I cross multiply, force multiplied by time. So change in momentum is Ft. In physics, Ft is what we call impulse, right? Is what we call impulse. This is what we call impulse. So you can see that impulse and change in momentum are equal. They are the same. All right, so we talked about earlier on that the unit of momentum can be kilogram meters per second or Newton seconds, and we stated that the momentum and impulse have the same unit and the same dimension. We can see clearly from here that change in momentum, if it is equal to impulse, and change in momentum, the unit for momentum is kilogram meters per seconds. What is the unit of force? Is Newton. The unit of time is seconds. So we can see that kilogram meters per second and Newton seconds are equivalent. Moving on, we have a problem, and it reads: a body of mass 6 kilograms in motion changes its speed from 8 meters per second to 15 meters per second in the same direction. Calculate the change in momentum. We have a body that is of mass 6 kilogram moving at 8 meters per second as its initial velocity, then changes its velocity as 15 meters per second, okay, in the same direction. So what is the change in momentum? The change in momentum, delta P, is equal to mv minus mu. That is the formula. So the change in momentum can be mv minus u. Okay? So which means the final velocity here is 15 meters per second. The initial velocity is 8 meters per second. So because the direction of the body's velocity is the same, we are going to use them like that. So the mass is 6 into the final velocity is 15 minus the initial velocity is 8. So that will be 6 into 15 minus 8, that is 7. So 6 times 7 gives 42 Newton seconds. If you like, you can say kilograms meters per second. Okay? But what if the final velocity's direction and the initial velocity's direction were different? What would it have been? So to draw the diagram, you have the direction of the initial velocity as moving from left to right, and the direction of the final velocity as moving from right to left. If you are considering the object that is in motion, if it is moving towards the right, it's the positive sign. If it is moving towards the left, it is a negative sign. Okay? That is what you need to know. So with that, the change in momentum is m, we've said v minus u, right? So that will be, change in momentum will be, the mass is 6 into the final velocity is negative 15 if we consider its sign, that is moving from right to left, minus the initial velocity is 8. So the change in momentum will be 6 into negative 15, negative 8 will be negative 23. So the change in momentum will be 6 times negative 23 will be negative 138 Newton seconds. Okay, so moving on, we have a problem here again, and it reads, a body of mass 9 kg in motion changes its speed from 20 meters per second to 15 meters per second in the opposite direction. Calculate the change in momentum of the body. So if I should draw a straight line, and let's say this is the body's initial position having a velocity of 20 meters per second, but its final velocity changes to 15 meters per second in the opposite direction. Okay, and the body is 9 kg mass. So if I want to find the change in momentum, the formula for change in momentum is mv minus mu, or we can factorize to say m into v minus u. So this is the final velocity, this is the initial velocity. So the mass is 9 into the direction for a body moving from right to left will be negative. The direction for a body moving from left to right will be positive. So therefore, the final velocity will have a negative sign. So that will be negative 15 minus the initial velocity is positive 20. So I don't need to write that. So that will be 20. That is going to be 9 into negative 15 minus 20 is negative 35. So 9 times negative 35 gives you negative 315. If we want, we can say kilograms meters per seconds or Newton seconds, whatever works. Okay, we have another problem here. It says a ball of mass 5.5 kilograms released from a height hits a smooth flat surface with a speed of 8 meters per second and rebounds with a speed of 6 meters per second. Calculate the impulse experienced by the ball. So this is the ball, let's say at a height, and this is the horizontal surface. When the ball is released, it had an impact with the horizontal surface and then moves upwards again. So it impacts the ground at a speed of 8 meters per second, but while it was leaving the ground, it left with a speed of 6 meters per second. Okay, so moving downwards will be considered positive, moving upwards will be considered negative. So what is the change in momentum? This will be the initial velocity here, this will be the final velocity, and change in momentum is mv minus mu. That is, change in momentum is m into v minus u. So the change in momentum is m. What is the mass? Is 5.5 into v is negative. We'll give it negatives. Negative. What is u? U is positive 8. So there's no need to write positive there because positive negative will make it negative. So that will be 5.5 into negative 6, negative 8 is negative 14. So that will be 5.5 multiplied by negative 14, and we will have negative 77 kilograms meters per second as the impulse or the change in momentum. Okay, moving on to the next question. It says a ball of mass 400 grams released from a height of 3.2 meters hits a horizontal floor and rebounds to a height of 1.8 meters. Calculate the impulse received by the floor. Gravity is given as 10 meters per second. Okay, so we have a ball that is initially at a height of 3.2 meters and it was released to hit a horizontal surface. The height was 3.2 meters. So as it hits the horizontal surface here, it rebounds, so it moved in the opposite direction. Okay, it moved in the opposite direction, let's say, to assume a final position here, which is 1.8 meters. That is what we have understood. So it asks us to calculate the impulse received by the floor. All right, so we will consider this in two cases. That is, the body first was released from a height to have an impact with the floor, and after it moved upward again. We need to know the velocities, okay? Because it's the velocities that will give us the impulse. So what is the velocity at which it hits the ground, and what is the velocity at which it leaves the ground during rebound? These are what we need to find in order to be able to find the impulse. So when the body was moving downwards, it was initially at a height here. So that is, we can say, for the first case, we can consider this as the first case and this as the second case, right? So I'm considering the first case here. U, the initial velocity, will be 0 meters per second. It was released from a height. So we can call that U1. So the final velocity as it impacts the ground will be what we will find. So using V squared is equals to U squared plus 2AS. So but the acceleration will now be gravity. So we can say GS. I can say V1 squared for the first case equals to U1 squared multiplied by 2GS1, right? So what is the final velocity? That will be V1 squared is equals to the initial velocity 0. That will be 0 squared plus 2 multiplied by gravity will be positive if a body is falling from a height, right? So this side will be positive, but if it is moving up, this side will be negative for gravity. So this side will be 10. Let's just use positive 10. Multiply the distance is 3.2. So that will be 0 squared is 0. 2 multiplied by 10 multiplied by 3.2 will have 64. So that is V1 squared is equal to 64. So if we want to find only V, we send it as a square root in the other side. V1 will be the square root of 64, that is 8. So V1 is 8 meters per second, which means it impacts the ground at 8 meters per second when it was released from a height of 3.2 meters. So, but what is the velocity at which it leaves the ground? That is going to be considered for the second case, right? So we can say when the body was moving upwards, that's the second case, right? So it needs to have the initial velocity u2. We don't know that, but we know that the final velocity will be 0 when it is released from the ground. When it reaches its maximum height here, at maximum height, final velocity is 0. Okay, so we already know that. So using V squared is equals to U squared plus 2GS. So because we are considering for the second case, we can say V2 squared equals to U2 squared plus 2GS2, right? V2 will be 0, so that will be 0 squared is equals to U2 squared, which we are finding, plus 2. Gravity will be negative 10 because the body is moving upward, right? Multiplied by the distance is 1.8. So 0 squared is equals to U squared plus 2 times negative 10 multiplied by 1.8. That gives negative 36. So we're going to have 0 squared is equals to U squared negative 36. So if I send u squared to the other side will be negative u squared equals to negative 36. So negative will cancel negative. U squared is equals to 36 then. So u will be the square root of 36. U equals to 6 meters per second. So it means it leaves the ground at 6 meters per second. 6 meters per second, right? That is, for the impact, this is going to serve as the initial velocity. 6 meters per second will serve as the final velocity, right? We are considering the impact with the ground. So if I should find the impact, which is the change in momentum, is m into v minus u, okay? That will be change in momentum is equals to the mass of the body is 400 grams. So 400 grams, if you divide it by 1000, then you have it as in kilogram. That will be 0.4 into. So what is the velocity? The velocity is, we're going to have the final velocity as -6 because it is moving up, while the initial velocity will be +8. Okay, so that will be -6 minus the initial velocity is 8. So the change in momentum is 0.4 into -6 -8 is -14. So the change in momentum is 0.4 multiplied by 14. That gives a change in momentum of -5.6 kilograms meters per second. So that is the impulse received by the floor. Moving to question 5, it says an object changes its momentum from 80 kilograms meters per second to 360 kilograms meters per second in 8 seconds. Determine the force required to cause this change in momentum. So we are asked to find the force required to cause this change in momentum of the object. Okay. The initial momentum is 80 kilograms meters per second. The final momentum is 360 kilograms meters per second. The time is 8 seconds. So the relationship between force and change in momentum are stated by the Newton's second law of motion, which is the force is directly proportional to the rate of change of momentum. When we talk about rate, we are dividing it by time. Okay, so force is equal to the change in momentum divided by time. The force is equal to, what is the change in momentum? Is the final momentum minus the initial momentum divided by the time. So that is going to be, the final momentum is already given as 360 minus the initial momentum is 80 divided by the time given in the question is 8 seconds. So that will be 360 minus 80, that is 280 divided by time is 8 seconds. So we're going to have 35 newtons as the force required to change the momentum from 80 kilograms meters per second to 360 kilograms meters per second. Okay, 35 newtons. Moving on to the question number 6, and it reads, a body of mass 8,800 grams is moving at 50 meters per second. Question A, calculate the momentum of the body. Question B, if the body is brought to rest, calculate the change in momentum. Question C is, what is the rate of change of momentum if it is brought to rest in 0.8 seconds? Okay. The mass is 8,800 grams. If you convert that to kilograms by dividing it by 1,000, we're going to have 8.8 kilograms. The initial velocity is 50 meters per second. So with the initial velocity, it asks us to calculate the momentum of the body. We know that the momentum, so that will be the initial momentum, is mass times the initial velocity. So that will be 8.8 times 50, and that will give 440 kilograms meters per second. So question B is, if the body is brought to rest. So it was a moving object and it is brought to rest. So it means the final velocity will be 0 meters per second. Calculate the change in momentum. Okay. So what is change in momentum? Delta P is final momentum minus the initial momentum. So what will be the final velocity? It will be mv minus the initial velocity is mu. If I want, I can substitute directly, or I can factorize mass. So that will be m into v minus u. So that is going to be, the mass is 8.8 into the final velocity is 0 minus the initial velocity is 50. So that is going to be 8.8 multiplied by 0 minus 50 is minus 50. So we're going to have 8.8 times minus 50. That will be minus 440 kilograms meters per second. So moving on to answer question C, which says, what is the rate of change of momentum if it is brought to rest in 0.8 seconds? So when you are talking about rate, you're talking about dividing something by time. So it asks us the rate of change of momentum. So which means we are going to take the change of momentum divided by time. So that is going to be minus 440 divided by the time is 0.8. So what is that? 440 divided by 0.8 is negative 550. Okay, 550 newtons, because rate of change of momentum is equal to force. All right, the rate of change of momentum is equal to force. If you can remember the Newton's second law of motion, which states that the rate of change of momentum is directly proportional to the applied force. So it means rate of change of momentum is equal to the applied force or the resultant force. So we're moving to question 7, which is as it reads: a body of mass 80 kilogram moving at a speed of 14 meters per second with a uniform acceleration of 5 meters per second squared covers a distance of 550 meters. Calculate the force applied to the body calculate the time taken by the body to cover that distance. So we have the mass of the body as 80 kilograms. The initial speed is 14 meters per second. The distance is 558 meters, and we also have the acceleration there as 5 meters per second squared. So it asks us to calculate the force. So from Newton's second law of motion, we also know that force is equal to mass times acceleration. So the mass given is 80, and we also have the acceleration as 5. 80 multiplied by 5, that is 400 newtons. So the second question is to find the time. From the equation of motion, if I am given the initial velocity, the distance, and the acceleration, I need to use the formula S is equal to ut plus half at squared. So the distance given in the question is 558 is equal to the initial velocity given is 14 multiplied by time plus half multiplied by the acceleration is 5 multiplied by time squared. So that will be 558 is equals to 14t plus half multiplied by 5 is 2.5. So that will be 2.5 t squared. So I can say this looks like a quadratic equation. So I need to bring it in a way that looks like a quadratic equation. So that will be 2.5 t squared plus 14t is equals to 558, right? 2.5 t squared plus 14t minus 558 is equal to 0. This is how quadratic equation looks. So if I should bring the quadratic equation, ax squared plus bx plus c is equals to 0, and I compare, a will be 2.5, b will be 14, c will be negative 558. A is 2.5, b is 14, c is equal to negative 558. So, and therefore x is equal to t. So if I want to find t is equals to minus b plus or minus the square root of b squared minus 4ac over 2a. That will be the quadratic formula. So t is equals to minus b is 14 plus or minus the square root of b is 14 squared minus 4 times a is 2.5 and c is negative 558, all divided by 2 into a is 2.5. So t is equals to minus 14 plus or minus the square root of 14 squared is 196 minus 4 times 2.5 times minus 558 gives minus 5580 all over 2 times 2.5 is 5. So t is equals to minus 14 plus or minus the square root of 196 minus minus will be positive, and 5580 all over 5. So t is equals to minus 14 plus or minus the square root of 196 plus 5580 gives 5776 all over 5. So t is equals to minus 14 plus or minus the square root of 5776 is 76 all over 5. So we can divide as time is equals to minus 14 plus 76 over 5, or time is equals to minus 14 minus 76 all over 5. So time will be minus 14 plus 76, that gives 62 over 5, or time is equals to minus 14 minus 76, that gives minus 90 over 5. So time is equals to 62 divided by 5 gives 12.4 seconds, or time is equals to negative 90 divided by 5 gives 18.0 seconds. But time is never negative. Therefore, time is 12.4 seconds, and that answers the question. So this question involves quadratic equation. If you do not know how to solve problems relating to quadratic equation, we have a video on this channel that explains quadratic equation, so you can watch it to have more understanding. In our next topic, we will be talking about collisions and type of collisions. We have 3 types of collisions. We have elastic collision, we have inelastic collision, and perfectly inelastic collisions. We will discuss all of that with examples. So if you have not yet subscribed to this channel, I will request you to subscribe and hit on the notification bell so that whenever a new video is uploaded, you can watch it. Okay? Thank you for your patience.